Hi, we'll continue. Okay. So now we'll study two examples to illustrate the computation for optimal allocation. So in this first example, suppose that a corporation has 260K accident reports available over a period of time, and that a sample survey is being contemplated for the purpose of estimating the average number of days of work lost per accident. Okay. Of the 260K accident reports, 150K are coded and the 110K are uncoded. So this is a population size. This would be stratum size. So we have two stratum. One is the coded stratum, the other one is uncoded stratum. And the coded forms could be processed on the computer directly, and whereas the uncoded forms must first be coded. So the cost will be higher for the uncoded, right? So the total budget is $10K, and it is assumed that cost for the sampling and processing for the coded one is cheaper, right? And for the uncoded one, we have to do coding first, so that's why we have a so this would be C1 and C2. Okay. And since the population, we cannot really investigate the all, so we are going to do the sampling. So the sampling is the stratified sampling, right? And so we want to do optimal allocation given the budget, and the information is cost and standard deviation and population size, right? Okay. So what would be the optimal allocation for this given the budget? Okay. So before we move on showing the solution, I would like to ask you to pause this video and try to solve the problem for yourself. Okay. So what is your answer? Okay, let's check. The first thing to check is which formula we want to use. Since the total cost is given, which is the $10,000, the formula we should use is this one. Okay. And H is 2, and C is 10,000. Okay. And we know NH, so this is known, right? NH known, and CH is known, and so SH is known partially. So the answer is this one, using this formula, right? So you can use this formula to obtain this. Okay. So note that even if S2, so the information we have is this one. So we don't know S2 directly, but we can write everything in terms of S2. So we write everything in terms of S2, and they cancels in the numerator and denominator. So the solution it doesn't matter in finding the solution. And the next step is to check whether the solution satisfies the constraint. The first constraint is the cost constraint. So this is the C1. This is N1. And this is N2. This is a C2, right? And this is total cost. And so the budget, so it actually satisfies. So as long as it is less than, so we may not have exact equality, but as long as equality holds as a less than inequality, then it's okay. The second constraint is this. So here we have what is this? We have 150k. So we have enough population size, right? So the answer, this one, is smaller. So this is n1 and 2. So they are final solutions. Okay. Now let's consider example 2. In this example, we now the constraint is is not the cost restriction. The constraint is the condition is the sample size. So the total sample size is given, and you wanna do optimal allocation. So and we don't need this information. So we assume that costs are all equal. So we just assume that they are all equal. So we don't care. So the formula we should use this one, right? And use this. So this is everything is known, right? NH, capital NH is known and SH is known. So we should be able to, and capital N, I mean the total sample size N 140 is known. So everything is known. So we should be able to compute the formula, compute it, and this is the solution. Now the problem is this guy, the first guy. So we cannot really, so, and if you write it as final solution, you cannot 104, 23, and 13. So this is impossible, right? Because you have a sample size, population size 100, and there's no way you can select 104 samples. I mean 104 elements from the population of size 100. So that's impossible. So we have to do something, and basically we just put everybody. Should be end. Everybody in the first stratum to the sample. So take them all, select them all, and then we have the remaining part is 40. So we allocate 40 to stratum 2 and 3. Sorry about the typo. So basically select everybody in stratum 1 and then do the optimal allocation using the remaining sample size, which is 40, to stratum 2 and stratum 3. Apply the same formula. So that is basically this one is N2, S2, okay, and then this one is N3, S3, right? So then that is the solution.